we're in Loch Erebol and we're doing some geological mapping, but here there's a very interesting little bit of vegetation which will be of interest. And the ground here is covered with this small, pretty dwarf arctic-alpine shrub, Dryas Octopetala. So it's very low lying, but the flowers stand up on a stem up to about 6 centimetres high, and that allows for the pollen and for the seeds to get dispersed by the wind. And Dryas Octopetala likes very dry soils, well drained and calcareous soils. So a stronghold of it in the UK is the Durness Limestone up in the far north and northwest of Scotland. And you get it in the Alps, in some of the high limestone meadows, and in Canada in the very far north of North America as well. So why is Dryas Octopetala related to the ice ages? Well, during the last ice age, when the ice advances and it's colder, then the climate is drier and colder, and so the Dryas Octopetala actually colonises further south and covers large areas of southern Europe and North America, where there are very large areas of Cretaceous and Jurassic limestone, so you get a much wider range during the glacial maxima. And because the pollen is dispersed by the wind, then you get these spikes, vast increases of the amount of pollen preserved in peat. And so you get this strong signal from the Dryas pollen, which is implying that it's much colder because it's got a much wider range. And so these glacial maxima, about 14,000 years ago, are called the Younger Dryas, the Older Dryas and the Oldest Dryas. So they're actually named after the pollen that you find in the peat at those ages. So there you are, Dryas Octopetala, what the ice ages are named after.